You ever have one of those questions that sounds, like it came from a little kid, but the more you think about it, the more you realize it's actually kind of genius? Well, today we're tackling one of those. Can we literally paint the moon?
So here's the big idea. What if every single person on planet Earth, all of us, took a laser pointer and aimed it at the moon at the exact same time? Could we do it? Could we make the moon turn red? I mean, come on, that has to work, right?
Whoa, hold on. Before we get too excited, we have to lay down some ground rules for this massive cosmic undertaking. So first, we're going to magically gather everyone on Earth into one spot where they can all see the moon. Let's say, over the Arabian Sea. Second, we wait for a quarter moon, so we have a dark, unlit part to use as our canvas. And third, and this is the magic part, we're giving everybody perfect, unshakable aim.
Done. Okay, so we've got our laser army ready to go. That's 7.5 billion people, each holding a regular old 5 milliwatt red laser pointer you can buy online. Oh, this is going to be amazing. And all those lasers together give us a combined power of 30 megawatts, which, I'll admit, sounds pretty beefy. 30 megawatts, but, well, in the vastness of space, it's kind of cute.
Yeah, and here's why it's cute. The sunlight that's already hitting the moon clocks in at about 6 petawatts. Our little 30 megawatt beam is, roughly 200 million times weaker. So the actual visible effect on the moon would be precisely nothing. You wouldn't see a thing.
200 million weaker?
Oh, well, that's a bit of a letdown.
But wait, no! We can't just give up. What if we just used more power?
Fine. Level 2 it is. We're upgrading everyone to a 1-watt laser. Now, these are the totally legal kind you find on sketchy websites. They can burn your skin, they can set paper on fire, and they are absolutely 100% terrifying. Oh, and giving one to everybody on Earth, that'll run us about $1 trillion. No big deal. So, after spending $1 trillion on dangerously powerful lasers, the amount of light we've managed to splash on the moon's surface is 0.5 lux. And just so you know, the light from a regular full moon, what we see from Earth, is about 1 lux. So we've done it. We've achieved half the brightness of normal moonlight.
Half? Yes, we are halfway there. We're doing it.
We're halfway to being as bright as the light the moon is already reflecting, all on its own. And we're still completely invisible next to the 130,000 lux of sunlight on the lit side.
Oh, right. Details.
Okay, fine. So our own moon is outshining us. That's embarrassing. But we're not quitters. There's only one solution here. What if we tried more power? All right, next level. We're now giving all 7.5 billion people one of those night sun searchlights. You know, the blindingly bright ones they mount on police and Coast Guard helicopters. And we're giving everyone a special lens to focus that beam right on the moon. And look at that! Progress! Our giant collective flashlight is hitting the moon with about 20 lux of illumination. So we are now officially brighter than the dark side of the moon. That's a win. But compared to the side lit up by the sun, we're still not even making a dent.
But we're getting closer. I can feel it in my bones. This has to work. Okay, but what if we tried even more power?
You're relentless. Fine. Everybody gets an IMAX projector. I'm talking a 30,000-watt, water-cooled lamp. Picture that crazy bright beam of light shooting out of the top of the Luxor Hotel in Vegas. Now imagine 7.5 billion of them, all pointed at the moon.
Yes, we did it! Look, our beam is finally strong enough to be seen from Earth. It's a tiny colored speck on the surface of the moon. We have painted the moon. The original mission is a success. Good job, team. Let's pack it up.
We could go home. We technically succeeded. Or what if we tried more power? We're so close to something truly ridiculous. I have never been more on board with an idea in my entire life. Let's do it. Okay then, we're going military grade. No more projectors. Every single person on the planet now gets their own Boeing Y-1. That's a megawatt-class chemical laser mounted inside a Boeing 747. It's basically a weapon designed to shoot missiles out of the sky. And would you look at that? We've done it. Our combined beam is now shining on the moon with the same brightness as the sun itself. We have matched a star. This is humanity's greatest moment. It is pretty impressive. It's also currently consuming about double the entire planet's average electricity usage. But hey, we're making a big red spot on the moon, so priorities.
What if we tried more power? Okay, this is it.
The final level. We are giving every person on Earth a copy of the single most powerful laser ever constructed by humanity, the beam at the National Ignition Facility. It can fire a 500 terawatt pulse. Now, it normally only does that for a few nanoseconds for nuclear fusion research, but for our experiment, we'll pretend it can run continuously.
There is, however, one tiny little problem. The second we flip the switch on these things, the sheer energy in the beams would instantly turn our atmosphere into plasma, flash igniting the entire surface of the Earth and, well, killing us all.
Wait, seriously?
Dead serious. But hey, this is a thought experiment. Let's pretend we survive that. Let's see the beams magically pass through the air. Now the problem is, what happens to the moon? See, at this power level, we're not just shining light on it anymore. We are physically boiling the rock off its surface. It's a process called laser ablation. And this is where things get really wild. Our lasers are now vaporizing about 2 meters of lunar bedrock every single second. This creates a massive cloud of superheated plasma that erupts into space like a jet. We've effectively turned the entire face of the moon into a giant rocket engine.
Oh my God. We built a moon rocket.
We did. And now we're firing that rocket, pushing the moon right out of Earth's orbit and flinging it into a brand new, very unstable path around the sun. From there, who knows? This new wobbly orbit means the moon will probably either get slingshotted into the sun, ejected from the solar system entirely, or maybe even come crashing back into another planet, which could be us. And you know what? After all of this, I think we can all agree that if that happens, we probably deserve it.